In this video, you're going to learn how to solve trigonometric equations using the quadratic formula. We're going to go through two examples together. Let's dive into the first example. So we've got tangent squared x plus 5 tangent x plus 1 equals 0. Now, normally what I would try to do is see if I could factor this trinomial into two binomials and then set the factors to 0 and solve. But unfortunately, this one, it's not factorable. So what are we going to do? Well, we can see it's like a quote-unquote quadratic equation. We have this tangent squared, or like the second degree. So what we're going to do is we're going to use this quadratic formula that you know and love from Algebra 1, right? But what you might want to do is you might want to do what's called a u substitution. What I mean by that is I'm going to say let u equal the tangent of x, okay? And the reason I'm doing that is because now tangent squared, that's like u squared, and then 5 tangent, that's like plus 5u, plus 1 equals 0. It looks a little bit more what we're used to when we think of quadratic equations. So when we solve this, we're really going to be solving for u, and that's going to be u equals negative b, or the opposite of b, so that's going to be negative 5, plus or minus the square root of b squared, that's 5 squared, or 25, minus 4 times a, which is 1, times c, which is 1, all divided by 2 times a. 2 times 1 is 2. So we have 25 minus 4, which is 21. So this is negative 5 plus or minus the square root of 21 over 2. Now, you see how this is u? Well, u really represents the tangent of x. So to solve for just x, I have to take the tangent inverse of both sides of this equation. So x is going to equal the tangent inverse of negative 5 plus square root of 21 over 2, and x is equal to the tangent inverse of negative 5 minus the square root of 21 over 2. Now let's go to the calculator. I'm going to do a little bit of rounding here, so hang with me. Now I'm going to have to make sure my mode is in radians, so if yours is not in radians, check that. Put it in radians, and then we're going to use the tangent inverse. That's how we solve for the angle. So I'm going to have to press the second key on my calculator here, and let's see what that comes out to. So the tangent inverse of, let's see here, got negative 5 plus. Now you might have to use some sets of parentheses, or you can do this in steps and get a value for this and then take the tangent inverse of this value. Okay, so be careful with that. And then, so I'm getting negative 0.21. I'm just going to round to the nearest hundredth. Okay, for this one, I get negative 1.37. Okay, now let's go to our unit circle. Where is negative 0.21? Negative angle, we go clockwise, just a little bit, right about there. That's going to be negative 0.21. So our reference angle, I'm just going to write as 0.21. Negative 1.37, this is like negative pi over 2, which is 3.14 divided by 2, which is 1.57. So this is like negative 1.57. So negative 1.37 will be somewhere right about here. So when I drop a perpendicular, that reference angle is 1.37. Now, depending on the instructions, okay, for this problem, if it says give all the answers between 0 and 2 pi, okay, that's once around the circle, we would want these angles not to be negative, but rather to be positive. The other thing we need to pay attention to is that tangent's negative in which two quadrants? The fourth and the second. Now, the calculator only gives us one answer because tangent inverse is restricted from negative pi over 2 to positive pi over 2. But we have to realize, okay, there's another possibility here. And what I can do is I can draw another angle here in the second quadrant with that same reference angle of 1.37. And same thing over here with this same reference angle of 0.21. But remember, we're measuring from the positive x-axis counterclockwise, right? So hang with me. So this is actually pi minus 1.37. Okay, so pi is 3.14 roughly, minus 1.37. That's giving me 1.77 right there. This one I'm going pi minus this little reference angle of 0.21, so 3.14 minus 0.21, that's giving me 2.93. Now over here, I could do 2 pi minus 0.21. 2 pi is about 6.28. That's giving me 6.07 right here. And this one I can do 2 pi minus 1.37, so 6.28 minus 1.37. A lot of calculations, right? But the main thing to remember is that with tangent, it's like a diametrically opposed. That's a fancy way of saying that this is like a diameter, meaning that they're apart from each other by 180 degrees or pi radians. So if it just asks for from 0 to 2 pi, you would just list these angles of 1.77, 2.93, 4.91, 6.07. That's in radians. If it asks for a general solution, what you could do is you could say, well, x, our angle, is 1.77 plus pi n, meaning if you add pi, you end up at this one, another pi, end up back at this one. As long as you keep going halfway around the circle, you're going to end up at one of these two angles where it's going to satisfy the equation. Of course, n has to be an integer. And also 2.93 plus pi n, where n is an integer. And you got it. So let's take a look at another example. Okay, see if you can do example number 2 on your own, and we'll go through it together. So we've got 3 cosine squared x plus 5 cosine x minus 1 equals 0. How would you solve that using the quadratic formula? While you're working on that problem, I just want to let you know that I have 2 courses for sale. I've got an Algebra 1 and an Algebra 2/College Algebra video course for sale. So you can check out the links in the description if you're interested in those courses. And if you just want to support the channel, you can join as a channel member. If you join at the additional videos level, you can get access to a number of videos. I've got over 120 videos on there now, where there's midterm and final exam reviews. There's my full geometry course, as well as my ACT and SAT courses, and I've got other videos on there as well. So check that out, join as a member, and I'll see you over there. But let's see if we can finish off this second example. Ideally, I would want to factor this, right, and set the factors to 0, but sometimes it's just not possible. And so I notice this is like a quadratic type equation, and I can use the quadratic formula. But what we're solving here for is not x, but rather the cosine of x. Now in the first example, I showed you how to do a u substitution, but once you realize the pattern that we're actually solving not for x, but for the cosine of x, you can jump right into it. So we've got negative b, which is the opposite of b, that's negative 5, plus or minus the square root of b squared, that's 5 squared is 25, minus 4 times a, which is 3, times c, which is negative 1, all divided by 2 times a, 2 times 3 is 6. So this comes out to negative 12, 25 minus negative 12 is like 25 plus 12, that's 37. So negative 5 plus or minus the square root of 37, all divided by 6. But that's the cosine of x. So to solve for our angle x, we're going to have to take the cosine inverse of both sides. So let's do that. So x is equal to the cosine inverse of negative 5 plus square root of 37 over 6. And x equals the cosine inverse of negative 5 minus square root of 37 over 6. Remember, we've got 2 answers, plus and minus. So I'm going to the calculator now. Again, make sure your mode is in radians. And to find the angle, I'm going to have to do the cosine inverse. On my calculator, I have to practice second cosine. And you may have to use like nested parentheses, or if you have a fraction key, you might be able to set this up as a fraction. Or you could do this, get a value for this, and then take the cosine inverse of this value. So let's see what we get here. Negative 5 plus square root of 37 divided by 6. Okay, and if I do, so I'm getting for this one approximately 1.39. And if I do the cosine inverse, let's see, of negative 5 minus root 37, I'm getting an error. Now, why am I getting an error? Well, you can see that when you do this part right here, the negative 5 minus square root of 37 divided by 6, this part here comes out to negative 1.84. Can the cosine of an angle be negative 1.84? No. Remember, the cosine is always in between negative 1 and positive 1, right? So the max is positive 1, the min is negative 1. It can't be negative 1.84. So this is an extraneous root or an extraneous solution or a false answer, right? So now let's go to the unit circle. Where is 1.39 radians? Well, we know that pi over 2, remember pi is 3.14, divided by 2 is 1.57. So 1.39 is going to be somewhere maybe like right about here. If I drop it perpendicular, That's my reference angle, 1.39. Okay, but cosine is positive in which other quadrant? The fourth quadrant. So I'm going to draw this same reference angle. Remember, the reference angle is the angle made between the terminal ray and the x-axis. See, that's 1.39. But if I'm measuring from the positive x-axis, that's going to be 2 pi minus 1.39. So it's like I'm backing up or subtracting 1.39. Now 2 pi we know is 6.28 minus 1.39 is about 4.89. Now if it just asks what are the solutions from, what are the solutions from 0 to 2 pi, I would just say 1.39 and 4.89. But if it says it wants a general solution, then we could say our angle x is 1.39 plus 2 pi n, where n is an integer. Okay. Now why am I doing 2 pi? See, if it was 1 pi, that's a half revolution. I'd end up here. If I add 2 pi, I end up in the same location where I'm going to get the same values, right? Same thing over here for 4.89 plus 2 pi n. So you just have to watch. If they're not across from each other, you're going to have to add multiples of 2 pi, where n is an integer. So great job if you're able to follow this video. If you want more practice working with solving trig equations, I'll put a video right there. Follow me over there. We'll get some more practice. I'll see you there.